All right, I think they closed the door, so that means we can get going. Oh, one more. The late guy to class. Can everyone hear me okay? I kind of get weird echoes up here, so it's very hard. All right, so today we're going to be talking about Dynamo for construction workflows. And I'm not going to PowerPoint slide you to death. Most of this is going to be interactive and showing off stuff in Revit and Dynamo. So the idea here is that a lot of people use Dynamo for architecture-specific stuff. I've been to a lot of like BIM roundtables or other VDC groups in Atlanta, and people are saying, hey, I work at a GC, why do I care to learn Dynamo? It seems really cool, but I don't have a use for it. And so I wanted to show some more practical things you can do with Dynamo and some things we already have a need for. Everything I'm going to show today is real examples from real projects. So none of it's made up just for class, which in some ways made it harder to get this presentation together because a lot of this stuff I had no plans of ever showing anyone except for the final product. So the key learning objectives here are we're going to learn construction-specific uses for Dynamo, some Dynamo basics, and identify tasks Dynamo could be useful for. I'll show you a little bit about the online community and the package manager. I'm not going to really structure it according to each of these things. I'm going to show you 4 examples, and these are going to be kind of woven through. And the examples I'm showing kind of build on each other. So I want it to be really interactive. If you guys have any questions, stop me as soon as you have them, because we're going to keep building on top of it. And it's going to be easier to teach you at the beginning than it is 20 minutes later when it's that and more piled on. So I guess before we get going, I'd love to know what everyone does, get a feel for the class. So who is general contractor? Would you raise your hand? All right. Architects. Got a couple of you guys. I won't make too many jokes. All right. Who has used Dynamo before? Okay. All right. Who feels they're an expert in Dynamo? Me neither. So bear with me here. Some of this stuff I'm sure you guys can probably point out mistakes I've made or whatever, but you know, I'm not learning Dynamo to be the best at Dynamo. I'm learning Dynamo to solve business problems. So just one more tool in your toolkit. Anyway, first example is this Halfin connection detail issue. So it's a job we had where as the general contractor, we were supposed to put all these embeds in your concrete, and then these Halfin connections come in and connect it to the curtain wall. Our subcontractor was suing us because they said that we got all these Halfin channels out of tolerance, and then they had to try and explain this to our lawyers and the mitigators, and they're not construction people, so they don't know what the details are. They don't really understand how tolerance is supposed to work. And so I was asked to give some kind of visual representation of how tolerance could work, use their system to do it, and then they use this in the court case. So this is the Halfin connection, and I'm going to show you how I use Dynamo for this. This is kind of the Giphy version of it. And so we're using Revit to make that family, which moves with different parameters, and then we're using Dynamo to animate and control it. So I'm going to get out of PowerPoint and jump into Revit with you guys. All right, so here's kind of what we were looking at before, and this is the view we were exporting from Revit to make the animation, and I'm going to jump right in. If you guys don't know, they moved Dynamo in 2017. It drove me crazy. It's over here under Manage rather than Add-ins. So let's look at that. Slowly look at that. Okay, so we have our first Dynamo definition here. This is one of those times I really wish there were 2 monitors. I don't know if you ever work in Dynamo, but you can't do it on one. It's really tricky. So but anyway, we have this connection. I'm going to try and show you it, and I guess we could start from the Revit environment. We have 3 instance parameters here, and this move this connection around. So let me show you how we drive that from Dynamo. So we start out, and we are trying to get that family instance, which is kind of starting here, right? And if you were saying, hey, I want to do a thing in Dynamo and I want to work with this thing, you can just kind of come in here and say family instance, and you're going to probably, well, I'm lying. Family instance. Dot. It's not working for me. It's getting me that time. But if you're looking for the Revit specific stuff, we can come at it this way too. We can go to elements, and then we can go to family instance. And there are many different ways of getting your family instances or adding instances or getting information about them. So we have these green things here, and these are typically how to create a new one. These red ones are typically how you get one out of the Revit environment. And then these green or these blue question marks are the information stored within it. So if we were going to do the by family type like I just have here and I already have set up, that's how we do it. So anyway, now we need a family type, right? And in this case, the family type is called health and model. So all I'm doing here is taking a string, passing it into something that goes and gets my family type, which is an object. That's the other thing here, is a string wouldn't go into something requesting a family type because it's the wrong type of thing. Even if in our brains health and model is the family type, to Dynamo you have to tell it that's a string, and then this is an object, and then we pass this object on. We're trying to get the correct data flowing through everything that we do. So family instance by family type, and at that point we would have the family instance. And in case there are multiple family instances, I wanted to get the first one. So I'm just getting, if there were a list of them that came out, getting 0, which is computer for 1. And then after that, we're coming over here and we are setting the parameter by name. So in this case, we're talking, this is the left value. That's the element that we just got through all those other nodes. And here's a number slider that we can move things around with. And we are going to switch this to automatic. Oh, I need to, delete that out. Okay, so now we just have those 3 parameters. We're on automatic, and this just moved slightly. But I can come in here, and now we can move this thing left and right. You guys see that? Cool. So now we're driving parameters straight from Dynamo in Revit Live, and we can come through here and slide it around all day. So we have that left and right motion, and the idea behind this family is to show that this channel is moving. As us, the general contractor, we put it, an inch to the left or an inch to the right. Well, how does this thing take up that kind of tolerance issue? We have the vertical here. So you can see this sliding up and down. Same situation here. We're just going for that instance parameter and changing the value. So those are how you could just animate that. And that was when we were talking to kind of see, is this going to be the thing to show the tolerance we need? It has all the range of motion needed to explain this, but you can't just open up Revit in front of a courtroom or in front of your lawyers and expect them to know what's going on. So we need to get something out of here that they find useful and valuable and can share. The thing that I had to do was to make animations in Revit, which isn't really possible, right? Revit doesn't do animations in any way. If you've done 3ds Max or any other program, there's some programs that do animations out of the box. They're really great, and Revit doesn't have that. It's just not what it's made for. But there's this dynamic numeric parameter, right? And this also doesn't come with Dynamo. This node was created by another member of the community. This was made by Håvard Vashag. He's from Sweden, and he made this in 2015. I think, let me pull up his information. Oh, spoilers. We can go check out his site where I found this. And he was using this for very different stuff. He was using this to animate window openings to show different daylighting. And so you could have all these window sizes change and animate He's also got camera movement and all these other things built in here, which is pretty cool. Here's that size changing thing I was talking about, which is cool, but it's not really something in construction we would get too worked up over. And let me show you how you get that into Dynamo. And I guess this is like a really good time to talk about Dynamo's community, because what's so cool is everyone can share stuff. His thing to animate window openings can be used to animate almost anything with this one is a numeric parameter. You can come into Dynamo and you can go to packages, search for a package, and when/if the internet is going to cooperate. Yeah. Dynamometer. So there it is. That's all you guys would have to do. You need to have this node. But there's tons of other stuff in here, and you can go for days figuring out what is interesting to you or what you'd like to toy around with. But it's a really good resource. So the next thing we're going to do is we're going to, for the interest of not letting my computer spin for hours, I'm going to change a few things on this node, and then I'll talk you through how this is going to work. Okay, so this node is a directory path node. It allows you to navigate to a file on your computer or a file location on your computer. And that is needed for the frames that we're going to export. And then we have a few other things. We have how many iterations. So this is how many frames are we going to export. The view, which you can use this little view guy here, drop down, and you can go and select your view live from the project environment. It knows all the views that are there. You have the minimum and maximum parameter value, which this is, I started this family at 6 inches as the center point, and so left and right in decimal feet is 0.416 and 0.583. I could have made that look a little bit nicer, but it works. And then the thing we're going to do is we're going to animate the left parameter of this family. And we are running. I should have switched to manual, but let me show you frames. And let's hope we don't crash. Okay, we can watch these things coming in live. Or we can watch one of them come in live. It's still not finished writing. Okay. I'm going to leave that running. I think it's still writing the rest of them. You guys have any questions? You guys want to sit down? You're not going to bother me at all if you want to rummage around for a few minutes and get in everyone's way. We got to wait on a computer for a second until I kill the computer and we move on. Any questions? All right. It's that after lunch grind. Everyone's kind of sleepy. Yeah. Yeah, so that's a good point. Let's see if we're going to... Well, I can show you that as soon as this is done running. But yeah, his Dynamometer is a package, and it's many nodes. And one of them is to modify a numeric parameter, and one of them is for a camera path. And if I remember correctly, you can move the camera along a line that you select or something like that, and then you can tell it how many frames along that line do you want it to export. So it's pretty cool. And so you guys saw these kind of still dumping out here. We got the first one. There's the second one. I don't know if you see that little shift. I think the third one's probably still cooking. And I can show you guys kind of the final product after exporting animations and then doing a bunch of video editing. Let's see, that's rendering pretty well. And we can, how do we make it 2 times speed? And so I guess I should say this box is something we just threw in there to show the zones that our tolerance said were okay. So this thing can move in and out of that zone. And that's just the channel part moving, and there's lot of words dubbed over this that I stripped out because it's kind of a legal case. And had the slab animating in the same way along with this. And then we can skip ahead a little bit to the actual connection. So here you can see the curtain wall mullion and our halfin channel sliding back and forth. And up and down. And we've got also ghosted out a copy directly on top of it so you can see it moving a little bit better. All right. Let's see if we're done here. We are. So that, to answer your question, Dynanimator package has camera movement, camera target position, camera fixed, all these different options in here. The numeric one, transparency, so you could probably turn things invisible and visible, etc. All kinds of other stuff. So it's pretty cool, and it's a pretty robust package that he has. It's pretty nice. And last call for questions before we move on. All right. No. We're going to shut this one down and open up. Going to do slab flatness, and well, I guess we're going to start with a fresh file here. Okay, and back to PowerPoint. Oh yeah, PowerPoint, nice. We did that. Slab flatness analysis. And this is something that you guys probably have done in other softwares before. There are other tools for it. But this was a good opportunity to try Dynamo out on it, and we don't do it that often. So slab flatness is when your slabs have dipped on existing buildings, or after pouring them, they're uneven. And in this case, we had terrazzo flooring going down on top of our slab, which is extremely expensive, and we had some considerable dips. So that means to get a level floor of poured on terrazzo, we would have had 2 inches of terrazzo in some places. It's cost a fortune. So they wanted to come in with concrete before they poured the terrazzo, level out the floors a little bit, find out where they needed to grind things down, and save a bunch of money that way. Some people, in probably most cases, they're going to be using a total station and going out and surveying points on your slab, laying out a grid. We've got a laser scanner, so it's a lot faster and really cool. But don't think just because you don't have a laser scanner you couldn't do something like this. This is kind of a scan of one floor, and you can see all the other mess on it. Laser scanners pick up everything, which is in some ways good, in some ways bad for this. In our software, we can take that laser scan and clean it down to this almost just the floor surface, but there's still some noise in there. The Dorito bags and the junk on your construction site is still in there in some cases. So later on, we'll have to figure out ways of filtering that out. So there's your slab. Then in our software, we turn that into a mesh, and we take that mesh and we lay out a grid system on it. So it drops points along it at a regular interval. And then those points, we had to clean and filter out as much as we could there. And then we exported those, and we're going to work with those in Dynamo. So if you had a stakeout grid from your slab, we're starting at the same point. We just got there a little bit different of a way. So let's go to that. All right. We're going to go straight into Dynamo for this one. There's no pre-existing stuff. We're going to jump to some files later because this is one of those kind of Dynamo definitions that you set to run and you go to lunch and you come back in an hour and you hope it's finished. But we can walk through the Dynamo stuff and learn a little bit of Dynamo stuff first. And the first thing I'm going to do is break that so we don't sit here all day. All right, so we have a file that we exported that looks like this. So these, for whatever reason, they exported out, and there's a lot of extra junk in here, but we have X, Y, Z coordinates, and then we have for some reason there's an empty row in between each of those, and there's an extra column, and sometimes that happens. And so one of the skills you can learn, hopefully today, is that how you can filter out your CSV files or any kind of point lists that you get, because you're not always going to get nice, clean data. So let's look at that. And so again, we're using that file path. And we are, is this working as a CSV? I might have screwed this up. Yeah. Sorry. Convert this to Excel. Same thing, just in Excel now. And Dynamo likes that better. Yeah, and now we've got this book name, and it should run. Yes, okay. So we had that list of points, and there were some issues with it, right? And we can kind of see already right here from this Excel read from file, takes the file from a path and the sheet name. That's all this thing takes in. It's pretty easy, and you can see that the Excel file kind of in Dynamo here. You've got that 1 and then 3 blank spaces, and then you've got your actual point and a 0, which is the same as this. So that's R1, 3 blanks, point, 0, etc. We need to clean that up. And this is kind of like list manipulation stuff. It's pretty important in Dynamo. A lot of the challenge is just converting your data and moving it around from one thing to the next. So, all right, so at that point, we use this next node here, list to take every nth item, which means that you can iterate through a list and only take every second item, every third item, every fourth item. We're going to take every second item, and we're going to start right here. So we're going to grab this one, and we're going to grab this one, and we're going to grab that one. And all of those 1 null, null, null rows are gone. And we've cut down from 49,000 points to 24,000 points, which kind of shows you some of the power of this, is because we're going to be putting in 24,000 objects into Revit here shortly, automatically. After that, we've still got a few other things, right? We've got this 0 we want to get rid of, and that's just because our point cloud software expects another value to put in there. That's why that exported. And so we flatten it one time, and now we have this list, this non-sublisted list, if that makes sense. It's one layer down. And then we go through here, and we're dropping every item with this node, which means every fourth thing in this, get rid of it. So 0, 0, 0, all the way down. Now we're going to go through and get all of our X, Y, and Z values out of here. And I may have gotten this wrong when I told you before, but we're going to use this list to take every nth item again, and we're going to use this time 3, and the offset this time is 0, which means that the first value is your Z value, I've got kind of labeled here. Then the third value is your Z value, etc. The X value, we're just going to offset that down one where it's 1, 4, 7, etc. Your Y value happened to be 2, 5, on and on. Now we've got these clean lists of each of these, and if you see your Z values, they're varying, but they're pretty flat, right, all the way across, which you kind of expect from a slab. It's relatively flat. Your X values change considerably because you're moving pretty far, and your Y values as well. The next thing to point out that we had to do is we had to convert meters to feet. There's this really easy node to use for that. You can come through here and select whatever stuff you want. We exported meters, had to go to feet in order to work in Revit. That's all it was. And so now we've got a point by coordinates, and we're plugging in X, Y, and Z. And we should, can we see these? This is our slab. It's coordinates for our slab in Dynamo, which is pretty cool because we got, that's 24,000 data points just rendered really quickly. And if I wanted to, I could run in and plug it into this family instance by point, give it this family object I call color tile, and we could start watching my computer spin. And it would start chugging these things through here. What I'm gonna do, not 2016, old habits. We're gonna import that family. And I'm going to just drop one of these in here so you guys believe that it actually draws these things. And again, stop me at any point in time if you guys have any questions. Oh, where do I have that? Oh, it's on my desktop. Okay, so whenever you're trying to put something into Revit automatically, it's always good to drop one in. So that way it's actually like fully loaded. And this is a generic model, so I think that's why we can't see it. No. Okay. Well, I'm struggling to figure out why this is working right now. But what we're going to do is we're going to jump on to black screen. Okay. We're going to jump onto the file with these already placed. Where are we here? Tiles in place. All right, so here we go. We've got all these tiles, and this is a family we're going to use a little bit more today. It's basically just a big square, and you can come through here and you can edit the sample dimension size. So in this case, our original points that we exported from the point cloud were 3 feet apart in X and Y direction. So that's why this is 3 feet. But later on, we'll be doing a 10-foot grid on kind of a survey, a land survey scale. So that's how that works, and we're going to jump back into Dynamo for part 2 of this. This is coloring. What we're going to do here is we're going to try and present this as something other than a big gray blob. Even if these are presented, or these are in Revit and they're in the right location, it doesn't really help you very much. So we need to color these in order to make it a little more clear. And another good thing to do when you're making Dynamo files is to separate your concerns out. It's kind of like a programming strategy where you want a script that does one thing, and then you can use that again and again and again. And also that last script would take hours to run. So every time I wanted to modify this, it would have taken all that time again. So here we are in a new file. We're starting out with family types, that color tile, so we're calling it. Getting all of those elements, getting that location again, right? So now that we've got a new file, we got to go back in and get our data points back out of Revit. And we're getting our Z value. So we got a location, which is a point. Each of those things is a point-based family. We're getting the Z value, and then we're going to start doing some work on that Z value. And so when you're wanting to color something in Revit, the node to do it is this element override in view. It takes a color and it works specifically in that view. So you could go and run this thing in different views and color your tiles in different ways. That color object is going to be an RGB color. And that means that our Z values that we got aren't going to be very helpful in making an RGB color right off the bat because they're 30 point blah, 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 blah. And it's not going to accept that. There's this really cool node in here called math remap range. And that'll take any range of numbers and redistribute them to a new range that you give. So this minimum and maximum is what we've done here. And so we've taken the entire Z value, the entire elevation range, and pushed it through 0 to 255. And we can then, I guess we make a color out of it. I'm going to run this, that way we can look at some data in here. It should only take a second. Again, questions at any point in time? Yeah.
The point that you got from your original scan is when you translate to the tile, is that the center of the tile that point out? Or?
Yeah, it's the center point. Think of those color tiles sort of as like pixels of color or data or however you want to do it. So, sort of like doing integration in school, if you remember, like trying to integrate a curve and you could just sample point it and get really close. It's that same kind of concept, but in 3D. So we could try and figure out how much volume is exactly there. This is a good estimate. That's a lot easier to do. Oh, come on, Dynamo.
Do you do most of your coding in Dynamo or Dynamo Studio?
I do it in the plugin. I really don't even have Dynamo Studio. They were kind of odd when they were doing the AU presentation stuff this year because they only call it Dynamo Studio everywhere. So it wasn't the plugin. You might be crashing. Oh. Maybe? Bear with me, guys. I'm sorry. See if there's anything else I can show you here. No? Okay. Are we finished? Any other questions while we wait?
You use that to grab things that were not Dynamo. Can you do it to grab things that are not that Dynamo?
What do you mean?
Say when you color code everything that wasn't that particular family, like maybe make it transparent or another color.
Ooh.
Use that Dynamo script to say grab everything that's not this particular chair type.
I hadn't thought about that. Potentially, I would think to do it the other way around. If you can get that list of whatever elements it is, the rest of the script will work. So I'm not sure what the best way to would be to select the rest of the instances. I think there might be every instance in your view type of things you can do, but I'm not sure. That makes sense. And I think I'm just going to kill this so we don't waste too much more time. Yeah.
Will you be able to go back to the program to tweak the parameter of the match and then or changing the intensity of the points and kind of like a parametric you change the output
The points were really made in a different program. And sort of the reason I did it that way is because if you're going to go out and survey a slab, you're going to do it one time. You're not going to go do it again. We could maybe filter these and take, divide it up and take every 9 foot rather than every 3 feet, if that makes sense. I could go back in the program and run it all over again, but that's kind of outside of the Dynamo stuff, and don't want to get too much into that. Okay, Revit. Oh, I'm sorry. Yeah. You're helping me out. I appreciate it.
Question, sir. Do you think it can be applied also to quantities coming from a site, let's say civil 3D or a survey, under a general contractor point of view? Let's say that I'm working on infrastructure, so we have one road and we need to do the widening, so we need to get the survey once every month. Do you think this can be applied to that?
It kind of depends. This is really to visualize your data. I'm not sure what kind of visualization you'd want to be doing from a road.
You want to simulate the progress.
Mm-hmm. Yeah.
You want to see, okay, I should be here, and I'm here, or I'm here.
Oh, yeah. This actually could be really good for that. If you go out and survey the new data every month, you could bring it into Dynamo, and you could just set one color for each month. And then you could keep the same file, open Dynamo every month, bring a new list in, color it, etc. Yeah. Let's see. You need some tweaking, obviously, but concept is very doable. We're going to skip ahead to that part has worked already portion. Tiles colored and tagged. So what I ended up doing was grayscaling it. And I'll show you in Revit or in Dynamo how you can change your colors and how you could tweak it, and I can show you some other examples, but I really don't want to run that script again without wasting everyone's time watching it spin. So those same data points we had, now they're colored. And so the higher points are whiter and the lighter points are darker. And so some of this data you could come through here and manually question. You could go, okay, this is the column, and I got points and columns in here. But there are other parts in here where you see this really nice smooth gradation, right? And you can imagine maybe there's a column here and here and here and here, and this is that pitting that you get in between your column grids over time. And so yeah, you could have that manual interaction with your data in a visible way, because excluding those bad data points programmatically would be quite challenging, but visually you could get into Revit and spend 10 minutes and clean up anything you didn't feel good about, run the script again, and it would re-average. Let me jump back into that script really quick. We're not going to run it, but walk you through the last little bits of it. Oh, that's the wrong one. So this ARGB, this is the grayscale. So we're varying red, green, and blue all by the same amount. So that is, if you have the same red, green, and blue value, that's somewhere between white and black. There's no distinct color. But we could just drop out some of these green and blue values and make it a big red scale or a blue scale or a green scale or whatever scale you want. And I've got some images of that. So there you go in red. And oh, that projector's not very good, is it? Sorry about that. Yeah, it's a little bit clearer here. Wow, is the grayscale better? That's the question. It's not too bad. Okay. That's how you could vary your colors up, and you could have many different schemes on color changing stuff there. At the same time, that Z value, we are subtracting and inserting that parameter into each of those tiles. Same way as the last presentation where we're setting parameter value. By name, we're taking each of those elevation points, which when converted into feet, we were saying we're supposed to be 100. We subtract that, and we know how far off each tile is from the ideal elevation. And with that stored in Revit, you could just do a little scheduling, and you could figure out how much concrete you would expect to order, roughly. Okay, so we are pretty much done with that one. And we're running a little low on time, so we can either kind of take that one step further and compare this to topography in Revit and see your the same kind of thing, how far your existing survey point differs from a designed topography. Or the last example I have, because I think we're only going to get one of these, is a fountain that we had big problems, or we had some real questions building, so from the design. All right, we're going to do hands. All right. Topography. Tile. Okay, cool. Tile's some new stuff, and it'll be interesting. Okay, and we're going to jump into PowerPoint. And so here's kind of the tile layout. I'm going to open up the real PDF here in a second, but I guess I ought to just do that now. Here we go. So here's that same sheet. I've kind of removed some stuff from it, but we have an elevation on the outside here that is constant, and we have a drain down in here and another constant elevation. And these squares are the tiles. These are like marble slabs that at the point they asked us to help out on this, we're on a boat from Italy or something like that, and they're ungodly expensive. And the thing is that someone had decided that a constant elevation here and a constant elevation here, even if it's higher, can somehow be a consistent slope over different distances. You get what I'm saying here? So like this thing is, it's kind of like a bowl-shaped thing, and they're kind of saying it's like a half-pipe shaped thing, or kind kind of V-shaped thing. It's called double curvature, where you're curving two directions at once. And this is a fountain where kids are supposed to play, so we got really concerned that these tiles aren't going to fit that curvature correctly, and they're going to be bumping up on the corners and tripping kids and people walking and all that stuff. They were getting the tile saws out ready to cut these things into triangles, which would have been really terrible, but we kind of tried to help prevent that. So we are in tile pattern, and I've got a few things here in Revit. We've got that outside circle dimension, and we've got the inner dimension, and we have a quarter of this actually modeled. If you look at the drawing again, the worst area for elevation change is actually down here. You see we're going the furthest distance from this point to this point in the shortest length, basically. So that's the worst area, and if this area works, then the rest of it will work. And it's also mirrored, so there's no point in reproducing all of that. And let's go to Dynamo. And these, I guess I should say, these are just floors, and because of the definition, we're just really averaging them. I could get the exact corners, but the definition would be a lot more tricky rather than squares or rectangular shapes. So oh. Cool. All right, so this is the entire script. I could show you guys a really funny picture of what this used to look like. It used to be this monster of spaghetti strings, and just a few weeks ago I redid it for the sake of this class. All right, so a few things to do here before we get going is let's cut that out of there and break that. And there's a few nodes in here we haven't really looked at yet. Select model element node. Let me show you how that works. You can come in here and hit change, and you can select something in Revit. And now it knows about it. If you do that here, you can do the same thing, and this is the inner circle. So now we have those in, let me show you, we have those in Dynamo, if this is going to cooperate. Okay, so we have those in Dynamo. The rest of the script is broken, but we'll fix that. And what we're going to do is we're going to loft between those two surfaces and make that double curvature, that idealized form that was drawn but not really thought through when you're putting down planar tiles. So first thing we do is we take that element, that line, and we get its location, which outputs its geometry. And then we're going to translate that down. And that means I can come through here, and if it's going to stay with me, we can manually lower that thing up and down to show different elevation changes, if you can see that. Just leave it somewhere in the middle there. And then this is that lofting thing. So we take that outer curve, that inner curve. If they're the same shape, you can make a list out of them. You can plug them into a surface by loft function, which is just going to make a geometry between two profiles. You can get in a lot of trouble there if you put the profiles in the wrong order, or they're not the right shapes, or whatever. Then we have another node here, which is called Select Faces. And this is how we're going to get those tiles into Dynamo. And we're going to see, oh, this is one thing to watch out for here. You can come through here and select them like this. This is all that top face. Oh, I just screwed that up. Do that again. Click the edge, and it's not going to like that. Okay, so you got those, and then up here it's going to have this little finish button. And it's got them. And let's go to manual again. We take those surfaces, and then we ask for the faces of those. And we get each of those corners, because that's where the new tiles are supposed to lay down onto this surface in an ideal world. And we convert those vertexes from the faces into points, and now we can start doing some cool stuff with them, right? The next part of that is we take that point and we draw another point down below it, and we can now intersect that with the lofted surface. so we can find out where that's supposed to hit. And we do that here with line by its start point, direction, length, and we just tell it go down 1 foot, or go negative, and then the length is 2 feet actually. And we can kind of see this. They're not drawing them yet, but I don't want to jump too far. So let's just draw those lines. Okay, you see those lines? And we're actually going to translate those up here in a second. So we move those up. Now we're sure they're going to go through that lofted orange surface. Now the next part of this is figuring out where those intersection points actually are. And if we, again, it's one part at a time. So those intersect, and you can see it kind of drawn here in Dynamo on that surface. It's not the easiest thing to see, is it? There you go. So there are the points. You can kind of see them from the bottom side a little easier than the top. Right on that surface, so where those tiles are ideally located on that surface. And you may be thinking like, okay, cool, we got the tiles on the surface, that's great. We're pretty much ready to go, but the problem is these tiles are still not planar, or these points aren't planar. If you think about like pushing a book into like a swimming pool or like a skateboard, like bowl, like you can only maybe get 3 of those corners down in most cases. It's like why your table rocks or your chair rocks at like uneven floor, because you can't get all 4 points down, and that's not going to exactly cut it for this. So unfortunate part of double curvature is you can't just make this match. But what we're going to do is kind of simulate that shimmying. You know, if you can imagine yourself laying this tile down, you can get 3 corners down. You would average it. You would kind of shift it around and squeeze it in the grout a little bit. And we're going to do that using this node called plane best fit through points, which fits a plane to the 4 points that we're extracting from the face, and then we're going to actually draw those lines through that face again. And so this is the best fit for that tile on that surface. And let me just get that running and show you what that looks like. Cut that off. It's a very, very slight tweak in most cases. And you can kind of see the planes drawn in here. And potentially we can see some of these double points. They're really, really close and really tricky to see. Okay, we'll see them in a minute in a little bit better way. So now that we have those points, we kind of want to get those into Revit. And we're going to use an adaptive component to do that, which is similar to a family instance, but it just takes 4 points. And it's a little bit more dynamic. And now that these are all planar and good to go, we can do that. This adaptive component by points probably looks a lot like your family instance by point that we had before. Getting a family type from this name, family type, etc. And we're chopping that out into those 4 groups of points. And everything should be good to go now. We should be able to run this. Cool. And, calm down. So now, you kind of see something just got drawn there, but let's turn these floors off. And you can kind of see the thing everyone was concerned about. So these tiles kind of have these corners coming up on them. They're a little bit scary and could maybe stub your toe on them. But now that it's in Revit, we've got all the Revit tools that we could use to test it out, right? We could drop an elevation on there. Let me find a good example. This will work. This is probably the worst case. And I'm going to try and make this remotely visible. Where is the, yeah, we're going to just turn that off. Is that the one? That was the one. So now we tagged that lower one. We're going to do one more on this top corner. All right. Isn't the imperial system great? So we can do the math on that, but that's what, 1/2 inch there roughly, and that's over a quarter. That's like 3/8 roughly. So we've got an 1/8 of an inch difference between those two corners. We have 1/4 inch grout between each of these tiles, and actually the elevation difference is a lot smaller than I'm drawing here. This is actually 0.15 inches, which some of you guys may be thinking, why were you concerned about that to begin with? But that's, what, 1.5 inches, roughly, or 0.15 feet, I should say, is about 1.5 inches. So in 2 tiles, 1.5 inches could have stubbed some toes, could have gotten some people worried. We can see what that looks like now. Iterate through how much closer we are. So 1/8 to 7/64 of an inch, so less than 1/8 of an inch in between these, in the worst case scenario on this whole thing. And that was pretty much enough for everyone to feel good about it and put the tile saws away and build the way we expected to. So any questions on this one? This is a lot.
How much time did it take you to do all that?
Oh, let me show you the original one. I've got images of it, and it's just embarrassing now. Oh yeah, it was this whole big spaghetti string thing. I mean, that was the whole thing. It's just so embarrassing that this is the way it worked, and it would spin for hours and hours and was nowhere near as reactive. But yeah, now that redoing it took two hours maybe just to really think through and make it in a way that you guys would all understand it quickly. So yeah.
Do you have anybody else in your firm who works on Dynamoga?
We've got a few people kind of toying around with it. Yeah, I probably use it the most, I would say. Daniel here, he works with me, and he's pretty good at it for a lot of the architectural problems we run into. Yeah. Anyone else? Yeah. I'm using a lot of. Yeah, the Dynamator animation one is good. I also like to program my own nodes in C#, which is something that I would have shown if we did the terrain thing, but I don't know if you guys, if there are developers around who want to know about that, just ask me. I can show you that. Well, so for our guys, this was our project team. We just got them on a meeting and said, hey, look at this. We're less than 1/8 of an inch in the worst spot. Don't worry about it. That's really all it was. And they had a hard time understanding that because they were freaking out. The owner was freaking out. The architect was not understanding the problem. And we just go, yeah, that's fine. A little anticlimactic, but it's good news for everyone. All right. Anyone else? Yeah.
How long have you been using Dynamo, and where would you point somebody as kind of the Dynamo for doing information?
The Dynamo users forum is pretty good if you have questions. If you want to just go from 0 to nothing, there's some good classes here, but I would probably look into some Lynda courses or some YouTube classes or something like that. I've been using it kind of on and off for like a 1.5 years. It's kind of a tool I use. It's not the one I use the most. I did Grasshopper in school, so it's a little easy to make the transition. Anyway, here's the tile when it was finished. Looks kind of cool. So real projects. If we have any other questions, we've got another minute or two. And if you guys would, please rate me on here. It'll help me to come back and hopefully show you some more cool stuff in the future. Any other questions? All right, let's call it. Appreciate it, guys. Thank you.